Hey everybody, how's it going? So last time we did something really amazing, which was actually draw our simple linear regression line through some data, and that's amazing. Today we're going to get a lot of intuition as to how training and test sets work because, look at this model. It fit our data pretty well, right? Except this was on data that it trained on. Like we used a formula that given this data, make this line. In the real world, we don't have just this data and we're trying to figure it, like learn about it. There's actually a branch of statistics where that is what this is about. But in machine learning, generally, we're talking about using this line for prediction, for using that y hat, which given some new x value, we want to be able to say, oh, if you're negative 0.4, well, what is your y value? I would guess it's here. Now, this is a little bit tricky concept because you would test this on data that we do have the y values for, such as the training set, but also on something called a test set, where I did talk about this a little bit in module 1, where, imagine that this data followed the same pattern. So we had some new set of data, and it followed the same kind of pattern up like this. Well, what we're going to find is that the model fits this training data, as in the MSE, which I can look at very, very easily as just y with this number of y list and predictions. Okay, that's our error function. It's 0.27. If I was to get another test set of information, just new information, new data, we're going to see that the MSE of that is going to be higher than it is for training. And the reason for that is because this line was made from this data. Like we looked at the data, we used some formula and said, okay, I'm going to draw this line through the data. Well, that's all that we can really do is to, given some training information, make a model, okay? But we need to make sure that this model is actually good at, it still has a strong predictive power on stuff that it hasn't seen before. And so what we're going to do is make this new test set of information. So data that follows the same type of pattern, and then we're going to see how our model performs on that. Okay, so to do this, well, we basically just do some copy and pasting from above. And so here, this data this is all about training. So now think about it versus training versus test. I'm not going to label all of this stuff as train because it would just be a bit of a pain in the butt, although you could. I'm just going to say basically the same stuff over again, but with test. So I'll say test data is equal to, well, okay, what do I actually want to call here? I'm going to do a lot of copying and pasting, but it's still generating data with the same parameters because that's what defines the relationship. I want it to have the same relationship. I should probably have it in the same range of data between -2 and 3 or so. Okay, and 20, well, that's the value, that's n. How many data points do we need? I mean, usually you end up having less test information than you do than train, so I'm going to make this number less. But you could have picked whatever you want there. Okay, so we have this test data, and then I can just say x list, or I'll just say test x list is equal to test data sub 0. Same thing as above, just copying and pasting really. Test y list is equal to test data sub 1. So now we have test information, and actually we can just plot this. We can go ahead, and let me separate the plotting from the making predictions a little bit. We can plot the test data here. plt.plot xlist, except we wrote it as test xlist. And instead of predictions, this is just actual values. And so they are test. That's not what I called it, is it? I called it test xlist. Yes, I did. And test y list. Okay, so if we plot that, then this is kind of crazy. We actually want a scatter plot, and that is not the right color. So if I add C is equal to, say, green, then that's our test information. And I'm just going to add a little bit more because I didn't really like how that looked. Let's add 20. And so here, okay, so the red is the training information. That's how the line was fit. And the green was this new testing information. Okay, so we are going to see, and it's maybe kind of tough to tell right now, but we'll see that the MSE for this is basically the red one, the training information. We'll see that the MSE of the test Y list and predictions, well, we need to get predictions, and so we can do this for the test above. So we'll say test predictions is equal to get predictions on, instead of X list, it'll be test X list, and model params, we are going to keep the same model. Okay, so this is saying what model do you want to use? Well, I still want to use this exact line, so I'm still going to use that exact same line. Okay, so if I do that, it seemed to be okay with what I wrote, and so I'm going to write down here test predictions, and so this value you can see is about double what it is for training. Okay, so there's a gap between training and test information, and this is pretty much always going to be true, and the degree to which is actually a really long story about underfitting and overfitting, which we will discuss absolutely. And hopefully that gave some intuition that, you know, we have some training information, we make a model, we want to see how well it does, and so we'll do that based off of this other set of data following the same type of pattern. And so we'll calculate the error for that, for the same model, but for that data, and it's going to be higher. And it's a big discussion here, but I will leave it at that, and I will see you in the next video.